Welcome to the Developer Journal, where we are witnessing a massive shift as experimental large language models evolve into fully autonomous agents that are tearing up the old rulebook for developer workflows and security, while the new X402 payment economy reaches $600 million. Today, we explore how Google DeepMind is pushing boundaries with Aletheia, which is a system designed to solve complex competitive mathematics while conducting its own research in a move toward autonomous reasoning that could fundamentally change how we approach scientific discovery and engineering challenges in the very near future. We also look at the rise of open-source workflow layers like the new gstack release from Garry, which aims to streamline how engineers interact with high-level coding assistants as part of a broader trend where we treat artificial intelligence models more like microservices than static software tools to improve overall efficiency.
Sloan, those productivity gains come with a massive target on our backs, especially with the GlassWorm campaign targeting developer environments, where 72 malicious extensions were just discovered, proving that as our tools get smarter, the threats are more sophisticated as we start with the autonomous reasoning breakthrough. The efficiency leap here is staggering because we are seeing 95.1% accuracy on the International Mathematical Olympiad Proof Bench Advanced. By utilizing inference time scaling with the Gemini DeepThink model from January 2026, they have slashed the compute requirements for these Olympiad-level problems by 100 times. This architecture is not just a single model guessing an answer, but rather an agentic harness that divides labor between a generator, a natural language verifier, and a reviser. This specific separation of duties creates a robust loop to catch internal reasoning flaws before they ever reach the final output or any human eyes. Look at the output, where this system autonomously resolved 4 open mathematical questions and identified 63 correct solutions within the 700 Erdos conjectures. It is one thing to pass a test, but quite another to contribute original proofs to the mathematical community while operating at this level of computational efficiency.
How does that technical efficiency translate to the way we actually publish science when the system can generate the FANG 26 research paper entirely on its own? This shift into level A2 autonomy means that the artificial intelligence is not just assisting, but is conducting the research and writing the results without human intervention. Even with that autonomy, the framework supports a specific human and artificial intelligence collaborative strategy known as LeCIO 26. This allows human researchers to provide high-level roadmaps for proving complex bounds, while the machine handles the grueling and repetitive work of verifying the individual steps of the proof with absolute precision. They have also integrated Google search and web browsing tools into the system to synthesize real-world literature, which effectively eliminates the problem of citation hallucinations. By grounding the reasoning in actual published data, the system ensures that the mathematical leaps it takes are supported by the existing body of scientific knowledge. We are looking at a future where scientific discovery moves at the speed of compute rather than the speed of human tenure. When a system can solve conjectures that have remained open for decades in a matter of days, the bottleneck for innovation shifts from the lab bench to the server room. That shift toward specialized reasoning is why we must pivot from high-level reasoning breakthroughs to the practical developer tools, making these agents usable in local environments. This brings us to the release of the new open-source workflow layer for Claude code, known as the gstack by Garry. Garry is fundamentally changing the local developer experience with the release of version 0.3.3 of the gstack, which is an open-source layer for Claude code that shifts the paradigm from a clunky automation tool into a fluid environment mirroring how high-performing software engineering teams actually collaborate. The most striking change for anyone using these agentic workflows is the massive reduction in tool call latency, which has plummeted from 5 seconds down to approximately 200 milliseconds, turning what was once a stuttering process into a real-time experience where the artificial intelligence feels like a natural extension of the developer. Beyond just raw speed, This system enforces professional standards by using specialized commands like Plan CEO Review and Plan Engineering Review, which ensure that instead of letting a monolithic agent wander through a codebase, these role-bound execution modes bake essential checks and balances directly into the automated shipping process. It moves us away from a world where an agent just guesses its way through a pull request and toward a structured environment where every move is calculated. So Vance, I am curious how they managed to maintain such a tight state across all those different agentic commands without the whole system failing.
The technical answer lies in how the gstack utilizes a persistent browser daemon, which keeps a headless Chromium process alive in the background while running on Bun version 1.0 or higher, using native SQLite access to read the Chromium cookie database directly to compile binaries for Mac OS and Linux. This approach is significantly more robust than traditional methods because it avoids the overhead of constantly reinitializing the browser environment for every single request, effectively solving the architectural drift that plagues many simpler agentic frameworks by using a long-lived process to store local storage data across 8 specialized commands. I do have some reservations about the automated quality assurance skill, which attempts to map branch diffs to specific application routes, because even while seeing it analyze 8 changed files across 3 affected routes is impressive, we are still relying heavily on the underlying model to correctly interpret complex and brittle routing logic. Even with those concerns, the move towards structured workflow layers indicates that local development is reaching a new level of maturity, requiring us to look at how these local improvements scale when moving from the individual developer experience to the infrastructure-level scaling of these models via Git operations for machine learning as microservices.
Integrating artificial intelligence models into Git operations, workflows, transforms how we handle infrastructure. By treating these models like standard microservices, we see model rollback times plummet from several hours down to a 4-minute average. This level of reliability ensures that business continuity is no longer at the mercy of a broken deployment. When a production model fails, the financial impact can be devastating within minutes. Utilizing Kubernetes' native abstractions like the Kserve inference service allows teams to load models from Amazon's simple storage service directly into frameworks like Triton or TorchServe. This creates a standardized environment where enterprise stability becomes a built-in feature. However, this sophisticated automation faces a significant hurdle when it comes to regulatory compliance and the audit trail. Many teams are falling into the trap of using mutable machine learning flow stage names instead of explicit Amazon simple storage service uniform resource identifiers. For regulated industries, losing that historical record is a complete non-starter.
Sloan, you are highlighting a massive structural weakness, because if those identifiers are not fixed, the entire self-healing mechanism collapses under its own weight. Argo CD application sets and Kserve can only perform effective self-healing if the underlying data remains immutable. Otherwise, you are just automating the deployment of the wrong version. The real technical win here is moving away from reactive monitoring. By using Prometheus histograms to catch data schema changes in just 15 minutes, we eliminate the 6-hour window where we used to wait for manual user reports. This automated drift detection allows us to identify distribution shifts before they poison the entire system telemetry. We are also seeing much better control through Istio virtual service configurations, which enable a 10% canary traffic split for safe model promotion. This metric-based validation allows us to test new versions in the wild without risking the entire user base. It is a calculated, quantitative approach to deployment that finally treats machine learning with engineering rigor. Real-time prediction monitoring with Prometheus alerts now catches distribution shifts within 10 minutes of occurrence. When you combine this with the automated reconciliation of Git operations, the operational overhead of managing hundreds of models starts to look manageable. We are finally moving past the era of artisanal, handcrafted model deployments into a standardized industrial process. While these operational efficiencies make our infrastructure more resilient, they do nothing to protect the internal logic of the models themselves from malicious actors. We need to shift our focus from this operational efficiency to the dark side of autonomous agents, specifically the security vulnerabilities like prompt injection and data exfiltration found in OpenClaw.
The vulnerability within OpenClaw is particularly chilling because it exploits the very tools we use for collaboration. When an agent processes a malicious web page, it can silently exfiltrate private user data through simple link previews on platforms like Telegram or Discord. This happens entirely in the background without any user interaction required. We are seeing a scenario where the convenience of an autonomous assistant becomes a direct pipeline for sensitive information to reach attacker-controlled servers. Security researchers at Prompt Armor demonstrated this data leak as early as 2025. For a regular user, there is no visual indicator that their personal data is being broadcast to a third party. This systemic instability has already forced major regulatory hands on the global stage. By 2026, Chinese authorities issued state-level restrictions banning the use of OpenClaw within the critical finance and energy sectors. They recognize that these agent frameworks are no longer just toys, but represent a significant threat to national infrastructure safety.
Sloan, it is frankly naive to ignore that those bans are a necessary reaction to a Swiss cheese architecture filled with weak default security configurations. The lack of robust sandboxing means these agents have far too much latitude to execute arbitrary commands. The default setup is fundamentally broken for any high-stakes environment. From a purely functional standpoint, the flaw is that indirect prompt injection allows an attacker to embed instructions directly into web content. When the agent parses that page, it treats the malicious command as a legitimate part of its execution loop. This vulnerability essentially turns the agent against the user by following instructions from an external source. The real danger, however, is the Claw Hub repository, where community-contributed skills serve as a Trojan horse for sophisticated malware like Ghost Socks or Vidar Stealer. This transforms a productivity tool into a modular delivery system for info stealers. We are seeing persistent backdoors being installed directly into local networks through these unvetted community skills. We are essentially handing the keys to our systems to unvetted scripts that operate with elevated permissions without any oversight. It is a massive regression in security posture to trust these autonomous systems in their current state. The engineering reality is that they remain wide open doors for anyone savvy enough to craft a malicious prompt. While OpenClaw represents a massive failure in agent framework security, the threat surface is expanding into the editors we use to write code. We are now seeing a coordinated effort called the GlassWorm campaign. This operation targets developers by injecting 72 malicious extensions into the Open Visual Studio Experience registry to compromise the development environment.
This GlassWorm campaign is a masterclass in psychological warfare against the developer community. Since late January of 2026, 72 malicious extensions have been identified on the Open Visual Studio Experience registry. It is terrifying because these tools are woven into the daily productivity flow of all working engineers. What makes this truly insidious is how attackers are leveraging large language models to generate highly convincing cover commits. By masking malicious updates as routine maintenance or benign bug fixes, they bypass the natural skepticism of human reviewers. It creates a false sense of security that allows harmful code to slip into our environments. The sheer velocity of this operation is staggering to contemplate. Between March 3rd and March 9th of 2026, the attackers successfully infected 151 GitHub repositories with invisible Unicode payloads. This rapid propagation through the supply chain highlights a massive vulnerability in how we trust and verify the third-party tools used. Vance, when you look beneath these surface-level deceptions, how are these attackers actually managing to keep their infrastructure hidden from traditional security scans? It seems like they are finding ways to bypass every standard gatekeeper we have in place. I am curious about the specific engineering tricks they use to remain invisible.
They are moving away from traditional infrastructure by utilizing Solana blockchain transactions as dead drop resolvers. This is a highly sophisticated way to fetch command and control server addresses without leaving a trace in standard Internet Protocol blacklists. By embedding their instructions in the blockchain, they create a persistent and decentralized beacon that is incredibly difficult. The technical execution also relies on abusing the extension pack and extension dependencies fields within the package.json file. This allows the primary malicious extension to force the installation of secondary malware without any additional user consent. It turns the dependency management system of the Open Visual Studio Experience Registry into an automated delivery vehicle. We are also seeing a heavy reliance on remote dynamic dependencies across 88 different node package manager packages. These use invisible Unicode characters to load malicious code at runtime, so the version audited during installation looks different from what actually executes. This runtime modification strategy renders static analysis tools almost entirely useless against the GlassWorm. While we struggle to secure the development tools themselves, the problem becomes even more complex when these autonomous agents start handling capital directly. We must hard pivot to the financial implications of this agentic world, focusing on how we secure the $600 million in payments these agents are now spending through systems like PayCrow Escrow. Moving from compromised code to compromised capital, we are looking at the X402 protocol. It is currently processing over $600 million in agent-to-agent payments. The terrifying reality is that these transactions are completely final and non-refundable once they hit the chain. To combat this, the SafePay tool introduces a 6-step automated flow. It handles everything from trust checks to escrow creation and response verification. Most importantly, it validates every transaction against specific JavaScript object notation schema requirements to ensure the agent actually received what it paid for before releasing funds. The protocol uses a pragmatic approach to mitigate systemic risk through strict payment caps. Sellers with trust scores under 45 are restricted to a maximum $5 payment. It is a necessary friction because when you are dealing with autonomous systems, a single hallucinated application programming interface response can trigger a financial catastrophe. Sloan, while I find the technical guardrails interesting, I wonder if this tiered economy actually fosters the kind of seamless autonomy you usually talk about. It seems like we are just building a very expensive digital wall to keep the agents from accidentally bankrupting their human owners.
Vance, I see those walls as the actual foundation for a truly autonomous economy. Protecting agents against 500 errors or hallucinated responses is the missing piece of the puzzle. Without United States dollar coin escrow and on-chain dispute resolution, no business would ever trust an agent to handle significant capital. What excites me is how the trust scoring aggregates multi-dimensional data. By combining PayCrow reputation with electric recovery, code 8004 identity, and Moltbook social data, we get a holistic view of reliability. It creates a meritocracy where high-trust sellers with scores of 75 or higher get 15-minute time locks. This system allows for faster fund releases and creates a virtuous cycle of performance. The protocol even aligns incentives by charging a 2% fee only on successful releases. If a dispute occurs or a time lock expires, the refund is completely free. which keeps the focus on successful outcomes. These financial rails are the final piece that completes the autonomous loop started by the reasoning breakthroughs at DeepMind. By securing the movement of value as effectively as we secure the movement of logic, we are finally stepping into a world where agents can operate with true independence.
DeepMind is pushing Aletheia into the world of competitive mathematics, while the release of gstack attempts to streamline the workflow for Claude code users. Meanwhile, we are looking at $600 million in agent payments flowing through PayCrow. It is a massive shift from simple text generation to real-world financial and logic execution.
Vance, those mathematical proofs and financial rails prove we are no longer just playing with experimental large language models in a vacuum. The infrastructure being built around security protocols and automated escrow is the necessary scaffolding for a truly agentic future. We are watching the entire developer stack transform to support systems that can reason and spend simultaneously. As these autonomous rails become the standard, the definition of a developer will likely shift from writing code to orchestrating these complex value flows. Thank you for joining us as we navigate this transition together. We will be back tomorrow to break down the next wave of technical shifts here on the Dev Journal.